Hi everyone. Okay, so one last thing that I want to talk about for rewriting, dressing up fractions, and that's fractions or quotients. And just like we use distributive property and factoring to rewrite products as sums or sums as products, we can definitely rewrite quotients as sums, and I'm sure we could go the other way too, and but we're not going to here. I don't even know what that would look like right now. So we're going to try and rewrite a quotient as a sum. And again, this is actually getting into operations a little bit. You could consider what we're doing dividing polynomials. But in general, a rational expression is a polynomial divided by a polynomial, so that kind of fits with rewriting rational expressions. So what I want to remind you of here is the fact that with fractions, if you have a common denominator, that means that the pieces that you're adding are the same size. So you have A pieces of size 1 over D and another B pieces of size 1 over D. So you can add them up and say, okay, if I add A and B together, that tells me my total number of pieces of size 1 over D. This property works in reverse, right? So you can add fractions with common denominators. You can also split a big fraction with addition in the top into little fractions. So we can split it up and say, okay, well really this means I need to take 10m squared and divide by 2m, and I need to take 8m and divide by 2m. And both of those reduce really nicely. I can, in the first fraction, cancel out a factor of 2, which will leave me 5 in the top and 1 in the bottom. I can also cancel out one of the m's, which will leave me a single m in the top. So it looks like I'm getting left with 5m from that first fraction. In the second fraction, I can cancel a factor of 2 and I get 4. I can cancel the m's out, and that just leaves me with 1 over 1. And remember, it does matter if you have nothing left in the top, that still the denominator stays a denominator, so you would need the 1. But here, where we have 4 over 1, we don't need to write 4 over 1. 4 means the same thing as 4 divided by 1. 4 does not mean the same thing as 1/4. So we need 1's on the top to show that it's a fraction. We don't need 1's in the bottom. So it's simplified really nicely, right? And really this would be the same thing if you just factored and canceled, but I want you to be able to think about it both ways. It gets more interesting when things don't divide in quite so nicely. So it is the same idea, but it's a different way to get there. Okay, so one more, rewrite the quotient as a sum. So you can split this up, and really this is mostly only a good trick if you are dividing. Okay, let me think what I'm trying to say. If you're dividing by a monomial, you could try and do it if you're dividing by something with 2 or 3 terms, but it starts to get pretty ugly. So this is something that we do when we only have 1 term in the bottom. 3r squared over 2r squared. Okay, so we'll get into this a little more at some other point, but right now I'm trying to keep it not too messy. So right now, notice my denominators aren't all going to cancel. And that's okay, and that's where this can get really interesting. For example, if you had an r to the 4th on the bottom, when you split this up, you wouldn't just get a nice polynomial, you'd still have some variables in the denominator. So this trick works. Again, we want to be able to generalize. This trick works whether the fractions cancel out nicely or not. So in the first fraction, I can cancel out an r squared, which means there'll only be a single r left in the top. So I have r over 2. Remember that that's the same as 1/2 r. You can write it either way. I don't have a preference. I really need you to know that they're the same. Otherwise, you won't always deal with one or the other of those correctly, maybe both of them. In the second fraction, I can cancel both the top and the bottom r squared. So r's are gone completely. R squared over r squared is 1. But I am left with 3/2. And then the last fraction, I can cancel the 2. I can cancel one of the r's. Here again is where it matters. What I'm left with is 1 over, that shouldn't be an equals, that should be a plus. What I'm left with is 1 over r. If you fail to write the 1 on the top, that is not at all the same thing, right? 1 over r and r are generally not equal to, with some very scarce exceptions. 1 negative 1, it would work. So it does matter if you cancel everything out of the top that you keep a 1 up there. Okay, and I think that's all my tricks that I want you to know right now for rewriting rational expressions. So variables within fractions.